So today we will see the applications of determinants. Okay. The first application is the Cramer's rule. We already discussed Cramer's rule. What is the Cramer's rule? Is to solve the linear equations. We took example of linear equations in two variables. But Cramer's rule you can solve it for any equation, any number of equations also. Okay, not necessarily two variables. If you remember, what we did is something like this. So we had a11x plus a12y equal to c1, something like this, and a121x plus a22, let me write it big, a11x plus a12y equal to c1 and a21x plus a22y equal to c2. Okay. So in a matrix equation, how it look like? A11, A12, A21, A22, and this will be A.
Sorry, XX and then equal to C1 by C2.
Okay. So in the Cramer's rules, what we found? So your x is equal to, if you remember, we defined three determinants, right? So one is a determinant D, which is nothing but determinant of this matrix. That is what? A11, A12, A21, A22, and then we determine another determinant dx, correct? Dx is what? Replace the x with this one. So it becomes C1, C2, A12, A22. And then dy will be replace y with this one. So A11, A21, and this will be C1, C2. So once you have done this, then your x is equal to dx by d and y equal to dy by d. Okay, so this is the way you can solve for the, we already saw this in the first class itself, correct? Some earlier class itself, I don't know which class it is. Okay, so this can be used for linear equations in three variables also. So what are the three variables? Let us say, for example, a11x plus a12y plus a13z equal to c1, a21x plus a21y plus a23z equal to c2, a31x plus a31, this is a22 na? A32y plus a33z equal to c3. If I am writing a mistake, correct me. So what will be the matrix equation? Tell me. This will be
A11,
1, 1,
A12, A13,
mm,
A21,
mm,
A22,
and a23. This one
A31, A32,
a33. Okay, and then here it will be
X, Y, Z.
and here this will be.
C1, C2, C3.
Okay. So after defining that, so then we have to define your determinant. D will be what? A11, A12, A13. Tell me.
A21, A22, A23,
Hmm.
A31, A32, A33.
Okay. And then we have to find out dx, correct? What will be dx? Replace the first one. X is first one, na? First one with this, correct? So what it will be? Tell me.
C1, C2, C3,
Hmm.
A12, A13, A22, A23, A32, A33.
Okay. Similarly, you can find out what other things, two things you have to find. dy and dz, correct? So let us try to find out dy and dz. So what will be a dy? Tell me.
A1,
A11.
C1 and A13
Hmm.
and A21, C2,
Hmm.
A23, A31, C3, A32.
And tell me what will be the last one? dz, right?
A11,
Hmm.
A12, C1.
Hmm.
A21, A22, C2. A31, A32, C3.
Okay, so what will be your x?
Dx by d.
Dx by d. Dx is this and d is this. Okay. And y?
Dy by d.
And z?
Dz by z. Dz by d.
Dz by z. d. Okay, so this is a way you can solve the any linear equation using Cramer's rule. You want to know the proof of Cramer's rule? How do you want to get the proof? How this comes out to be x? Okay, so let us try to prove it. Okay, fine. So, well, let us keep this one up to here. Okay, so let this be d. So we are going to now see the proof of Cramer's rule. Proof. So we are having d, correct? So let me multiply x with d. If you remember last time, if you remember one of the property of the determinants, okay, we had one property. Okay, you should remember all the properties. Yes.
All the numbers inside you get multiplied.
No, that's one matrix. No, this is not matrix, it's determinant. Na? If any two rows, oh no, that is not zero. If each element of a row or column of determinants multiplied by a constant k, then the value of the new determinant is k times the value of the given determinant. So if you want to multiply x into d, that means any row or column you have to multiply with this. Okay, so if you multiply this with x, that will be this. So this will be equal to x a11, a12, a13, x a21, a22, a23, and this will be x a31, a32, and a33. Correct? Am I right? Because then this if is there, then the determinant will be x times the determinant of this. That's a property we proved. So now from here, if you actually see a11x will be equal to c1 minus, okay, let me substitute this one. Am I right? In the place a1x, I can take all this term right hand side, correct? So this will be what? c1 minus a12y minus a13z, correct? And this will be a12, a13. And similarly for this, it will be C2, tell me.
C2 minus A1, A22.
This is A22y. A22y
Minus A23z.
3z. Okay, because I am taking from here. Because x81. Next, and this will be A22 and A23. Maybe not, the space may not be sufficient. So what about A31x? I can do it here, right? So this will be C3 minus, this thing will go here. A32y minus,
A33z.
what will be here?
A32, A33.
Okay. Yeah, so now, if you remember, there was one more property also we had, correct? If you remember, if any column or row is having some additive term, then you can write as a sum of three determinants. If you remember last time we draw that big determinant, I thought we can't write it, and it's a long one. What is that? Yeah. If each element of a row or column is expressed as a sum of two numbers, then the determinant can be expressed as sum of two determinants. You got it? So, if you remember what we did is, so if you had something like a11 plus x, a12 plus a13 plus, or I will write it like this, a12 plus x or x1, x2 plus a13 plus x3. And here is A, tell me, A21, A22, A23, A31, A32, A33. So this determinant can be written as A11, A12, A13, A21, A22, A23, A31, A32 and A33 plus this one X1, X2 and X3, A21, A22, A23, A31, tell me, A33. Okay, so this is what you can write. So I can use the same property. This is a property we proved also. So this property I can use it here. This is, we prove it, we show it for row, we can actually do it for column also. Okay, so what happens if it's a column wise? So if I write instead of this, if I have column, that means what? So this is plus x2 plus x3. So then what happens? The same thing, this will become x1, x2 and x3. This will be, what will be? A of 1, 2 and A of 1, 3. Correct? You got it the same way. So then we can write this as a sum of 3 determinants, correct? C1, C2, C3, A1, 2 and this one plus minus this one minus this one, correct? So let us write it down. Okay. So then, so this is xd, correct? Xd is equal to determinant 3 C1, A12, A13, C2, A22. Tell me. Then minus, tell me, A12.
It should be A12, A12Y.
A12Y, na? Correct? Yeah, A12Y.
And then A1. Then B, okay, A1, A12.
A12. This?
A13.
Tell me next. What is that?
A22Y. A22, A23, A32Y, A32, A33.
A33. Correct? One more term is there, second term, right? So this is what we taken this term. Now this term is also there. So this again is a minus. So we have one more minus term. And then we will write it what? Tell me what is it?
A13Z.
A13Z.
A12.
A12.
A13.
A13.
A23Z.
A23Z.
A22.
22 and A23.
A23.
And this will be?
A33Z. A32.
A33. Now again, see the y is a constant multiple. I can take it in front of, multiply it with that. Y times the determinant, correct? So similarly here z also. Okay, so then what will I do? I can take this y commonly outside and write it out, correct? So this will become, so I remove this y from here and write it in the front. Correct? Similarly, I can remove this z from here and write it in the front. Am I right? So we will write it as minus z. Okay. Now what is the value of this determinant? Tell me. Can you see? This column and this column, they are same. There's another one property we saw. If you remember, if any two rows or columns of determinant are identical, then the value of the determinant is 0. Okay, so we proved that also in the earlier class. You see the lecture. Okay, so this column and this column is equal. Therefore, this determinant is 0. Correct? And again come here. This column and this column are identical. Therefore, this is also equal to 0. So, therefore, what we are having xd is equal to C1, C2, C3, A12, A22, A32 and A13. Tell me.
A23.
And A33 divided, correct? So, therefore, x is equal to, so from here, therefore, x is equal to what? This divided by d. That's what the answer is. This is what? This is dx. Am I right? Huh? So this is nothing but your dx. Therefore, x is equal to dx by d, and that's what you have proved. Okay, so similarly you can prove it for y also, the same way you can do. Then your y term will come here, take these terms other side, you can prove it away. And z also takes the term and take all that to other side, then this will come out and those other two determinants will goes to 0. So you will get your, you will get the answer. Yeah, that is what the proof of Kramer's rule. Okay, so this is one of an, so the Kramer's rule, because I have proved it for 3 cross 3. In fact, you can do it for any matrix also. So therefore, Kramer's rule is an easiest rule. There is a good rule to solve this system of linear equations. Okay, and yeah, there's another one interesting. Actually, I think this continues with your in your 10th standard. You remember you had one thing, something called as consistency of equations. Whether two equations are consistent or not. Okay, so this actually can be shown nicely. If I again, what they given in the book is, if I give you a linear equation in 2 variables, and if I have given you 3 equations, and if I give you, so then for the 3 equations to be consistent, so you have to, how to put it? Okay, fine. Let me tell you. So, what the consistency of 3 equations in 2 variables. So, what is the form you will have? Yeah. A11, no, they have written as A1 only. Okay, fine. So this is A1x plus B1y plus C1 equal to 0. A2x plus B2y plus C2 equal to 0. So if I give these 2 equations, you can solve it. I am giving you one more equation. A3x plus B3y plus C3 is equal to 0. And now I am asking you a question, whether this equation is consistent with other 2 equations. What I mean is, you solve for this 2 equation, get some x and y. If you substitute this x and y, will this equation be satisfied? If it's satisfied, then we call the equations are consistent. Correct? So, and so what it says is, so we can show it. So for the equation to be consistent, if these 3 equations to be consistent, its determinant should be equal to 0. A1, B1, C1, A2, B2, C2. Tell me. Okay, this is the determinant of this equation. Correct? If this is equal to 0, then we can say these equations, these 3 equations are consistent. Okay. We will prove it now. Proof. Okay, so what's the proof? So let us take first 2 equations. Given this, let me write down this equation as 1, 2 and 3. Using 1 and 2, we can solve for x and y. How we will solve? Kramer's rule. Correct? So using 1 and 2 and Kramer's rule. So what will be the x, you tell me? These 2 equations, na? Okay, if you want to write it first in matrix form, tell me what will be the matrix form.
A1, A2.
Then I should write this. We have, tell me the matrix.
A1, A2.
A1,
A2.
here, A2.
B1.
Tell me fast. What is that?
A1.
A2.
B1. B2. C1. Oh, sorry, C should be there. x y
Hmm.
is equal to minus c1
Hmm.
minus c2.
Okay.
Ah,
So then using Kramer's rule, solve for x. What will be the x?
x minus c1
That is a dx, right? Minus c1
minus c2
Hmm.
b1 b2
b1 b2 divided by
a1 by
correct.
a1
Oops, sorry, this is determinant, not matrix. What is the matrix?
a1 a2 b1 b2
Okay. What will be y? Tell me.
by equal to a1 a2
Hmm.
minus c1 minus c2 divided by a1 a2 b1 b2 a1 a2 b1 b2.
b2. Okay. So now the point is what happened? What I said, if these three equations are consistent, you solve for x and y from these two equations. And if you substitute this x and y in this equation, okay, so that should satisfy. So let us take the condition, let us assume this equation is satisfying. And we will see if it satisfies, this condition should come up. Okay, so let us try to find it out. Let us substitute this x and y here in 3, okay. In 3. Tell me what it will be. So a3 x, correct? What will be x? Tell me. Minus c1 minus c2 b1 b2 divided by a1 a2 b1 b2 plus, tell me, b3 into
a1 a2
a1 a2
minus c1
minus c2 divided by
a1 a2 b1 b2
okay plus c3
c3.
equal to 0. Now if I multiply this whole equations with the, see the bottom is same determinant, na? I can multiply with everywhere. Anyway, right hand side is 0. So I multiply, then this will what happen. So then this will become like c3 into a1 a2 b1 b2 to 0, correct? I am multiplying everywhere like this, correct? This is right now. And now you tell me what it is. This is nothing but, yeah, see, this is basically what happened, A3 and the, what you call, I guess I missed a sign somewhere else. Oh, yeah, this minus sign I can take outside, na? Okay, so this will become, so then minus A3 into C1, B1, C2, B2, then minus B3,
a1 c a1 c1
A1, A1, C1,
a2
A2,
c2
C2 plus C3 into A1, B1, A2, B2 equal to 0. Okay. Okay. Now let me do one jugglery. Let me swap this column. If you remember, we had another determinant property. The moment when you swap the columns or rows, the determinant will change the sign, correct? So I can, since it's minus, if I swap, if I write B1 here and C1 here, That means I am swapping it. So then the determinant becomes minus. So that minus will become the plus. You got it? So what I'm saying is this is minus A3 into minus determinant of B1, B2, C1, C2. Correct? So this is minus of this. So now minus minus becomes plus. Right? So let us then minus B3 into A1, C. What was that? A1, C1, A2, C2 plus C3 into A1, B1, A2, B2 equal to 0. Correct? So this will make it as, so minus minus becomes plus. So this will eventually change it to plus A3. Correct? Am I right or wrong? A3. Now what is this? Isn't it this one? If I give you a determinant like this, A3, B3, C3, okay? And this, so if I take this is a cofactor of it, right? So what will you say? I'll write as B1, C1, B2, C2, and so this is B3, correct? C1, C2, so A1, A2, and finally C3, you see, C3, A1, A1, B1, A2, B2, correct? Isn't that same? Okay, so that's what we are, I guess, yeah, okay, yeah, you can always swap it down, correct? So it makes it negative, one minus sign, doesn't matter, anyway it's 0, right hand side is 0. So therefore this will be, so therefore A1, B1, C1, A2, B2, C2, and A3, B3, C3 will be equal to 0. Actually, anyway, even though it will be positive only, because see, we are swapping 2 times. What happened? First we are swapping this and this, correct? That makes it one negative. So A1 will go above and A3 will come down. And another one swapping we do. Then A3 and A2 will swap. So that will also have another minus sign. So even though it won't be positive only. Okay. So remember, that's why I wrote it in a one step. Normally this is a very, it can create lot of careless mistakes. Because in a one step I use 2 swappings. You got it? See, it appears I just moved this down and I moved these 2 up. But you shouldn't do this. You should step by step. In exchanging A1, this we call row 1, row 2 and row 3. Okay. First thing is row 1 and row 2 exchange. You have to write that R1 and R2 exchange. And then after exchanging, then R2 and R3 has to be exchanged. R3 has to be exchanged with R2. Okay, in the exams you should write step by step. If you jump it like this, usually they cut the mark. Or you have to at least write first performing R1, R2, interchanging R1, R2, and then R3, R2 you will get like this. Okay? Yeah, so this is the, so no, triangle. Collinearity. Other proof and stop பண்ணிடுறேன். நாளைக்கு வந்து நம்ம இது பண்ணலாம். Now, let me do one jugglery. Let me swap this column. If you remember, we had another determinant property. The moment when you swap the columns or rows, the determinant will change the sign, correct? So I can, since it's minus, if I swap, if I write B1 here and C1 here, that means I am swapping it. So then the determinant becomes minus. So that minus will become the plus. You got it? So what I'm saying is this is minus A3 into minus determinant of B1, B2, C1, C2. Correct? So this is minus of this. So now minus minus becomes plus. Right? So let us then minus B3 into A1, C, what was that? A1, C1, A2, C2 plus C3 into A1, B1, A2, B2 equal to 0. Correct? So this will make it as So minus minus becomes plus. So this will eventually change it to plus A3, correct? Am I right or wrong? A3. Now what is this? Isn't it this one? If I give you a matrix, a determinant like this, A3, B3, C3, okay? And this, so if I take this is a cofactor of it, right? So what will you say? I'll write as B1, C1, B2, C2, and so this is B3, correct? C1, C2, so A1, A2, and finally C3, you see, C3, A1, 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 B1, A2, B2, correct? Isn't that same? Okay, so that's what we are, I guess, yeah, okay, yeah, you can always swap it down, correct? So it makes it negative, one minus sign, doesn't matter, anyway it's 0, right hand side is 0. So therefore this will be, so therefore A1, B1, C1, A2, B2, C2, and A3, B3, C3 will be equal to 0. Actually, anyway, even though it will be positive only, because see, we are swapping 2 times. What happened? First we are swapping this and this, correct? That makes it one negative. So A1 will go above and A3 will come down. And another one swapping we do. Then A3 and A2 will swap. So that will also have another minus sign. So even though it won't be positive only. Okay. So remember, that's why I wrote it in a one step. Normally this is it can create lot of careless mistakes. Because in a one step I use 2 swappings. You got it? See, it appears I just moved this down and I moved these 2 up. But you shouldn't do this. You should step by step. In exchanging A1, this we call row 1, row 2 and row 3. Okay. First thing is row 1 and row 2 exchange. You have to write that R1 and R2 exchange. And then after exchanging, then R2 and R3 has to be exchanged. R3 has to be exchanged with R2. Okay, in the exams you should write step by step. If you jump it like this, usually they cut the mark. Or you have to at least write first performing R1, R2, interchanging R1, R2, and then R3, R2 you will get like this. Okay? Yeah, so this is the, so no, triangle. Collinearity. Other proof வந்து ஸ்டாப் பண்ணிடுறேன். நாளைக்கு வந்து நம்ம இது பண்ணலாம். நாளைக்கு ப்ராப்ளம் சால்வ் பண்ணிட்டு இருக்கலாம். சரியா? ரெக்கார்ட் ஆகிட்டு இருக்கா? மைக் ஒழுங்க மாட்டிட்டு இருக்கலாம். சரி, வாங்கணும் வாங்கிட்டு போயிடுற. Okay. So one more interesting application of determinant is to find the area of a triangle. Okay. How do you find area of a triangle? Area of a triangle. So what is that area of a triangle we write is, suppose if you have this coordinate system. Okay. And I am having 3 points. Say A, which is x1, y1, maybe B, which is x2, y2, and another one point may be C, that is x3, y3. So joining these 3 points is going to give you a triangle. Okay. So in determinant, so what we can find is the area of the triangle. Area of triangle ABC will be half x1, I think x1, x2 and x3, y1, y2 and y3, y3 and 1, 1, 1. Once if you find out the determinant, no, and that will be your area of a triangle. Okay, you got it? So let us prove it. Okay, how we are going to prove? Okay, the proof is it is easy only, but you have to do it in a more lengthier way. So I am going to drop this reticles down. Okay, so what you want to find out? You want to find out the area of this triangle, correct? So how I can do is, so the area of this triangle is, okay, and let me call this points as A, B, C, D, E, F. Okay, so what is A, B, E, D? That's a trapezium. And B, C, E, F, that's also a trapezium. So one more interesting application of determinant is to find the area of a triangle. Okay, how do you find area of a triangle? Area of a triangle. So what is that area of a triangle we write is, suppose if you have this coordinate system, okay, and I am having 3 points, say A, which is x1 comma y1, maybe B, which is x2 comma y2, and another one point may be C, that is x3 comma y3. So joining these 3 points is going to give you a triangle. Okay, so in determinant, so what we can find is the area of the triangle. Area of triangle ABC will be half x1, I think x1, x2 and x3, y1, y2 and y3, y3 and 1, 1, 1. Once if you find out the determinant, no, and that will be your area of a triangle. Okay, you got it? So let us prove it. Okay, how we are going to prove? Okay, the proof is it is easy only, but you have to do it in a more lengthier way. So I am going to drop this reticles down. Okay, so what you want to find out? You want to find out the area of this triangle, correct? So how I can do is, so the area of this triangle is, okay, and let me call this points as A, B, C, D, E, F. Okay, so what is A, B, E, D? That's a trapezium. And B, C, E, F, that's also a trapezium. Area of this trapezium, so let me mark it down. How will I mark it? So this is the, okay, fine. So this is the trapezium. This is one trapezium, okay? And this is another trapezium, okay? And finally we are having the, so this trapezium, area of this trapezium plus area of this trapezium minus area of this trapezium, correct? Am I right? This trapezium. So that will give you the area of this triangle. So let us write it down, tell me. So this is a proof we are doing. Area of triangle ABC is equal to area of trapezium. What is the first trapezium? Tell me. ABED plus
area of trapezium BCFE.
BC FE, then minus
minus area of
trapezium ACFD. Now you know what is the area of a trapezium? What is the area of a trapezium? Suppose if you have a trapezium okay, so of this length is A and this is B, and if the length is H, what's the area of a trapezium? Half. Area of this trapezium, area of a trapezium will be half H into A plus B. Okay, so now you tell me what is the area of these trapeziums. So now you know all this well. You know what is the height also. That is this distance, right? So and what will be the height? This is x1, na? This is x2. So this distance is x2 minus x1. Am I right? Tell me. So what it will be? So the area of a trapezium ABED. ABED is what? So this length is y1, this length is y2, and this height is x2 minus x1. Correct? So that will be half. So the height is x2 minus x1, and the height will be this is y1 plus y2. Correct? y1 plus y2. And then, yeah, right, then plus half, and tell me what this will be?
x3 minus x2.
Correct, x3 minus x2 and
y3 plus y2.
correct, y2 plus y3, correct? And the last one is minus half this trapezium, right? So if you take this is the height, correct? What will be this one? Tell me.
x3 minus x1.
x3 minus x1 into
y1 plus y3.
correct, y1 plus y3. So this is the area of the trapezium. Now you do this juggler, you will see it will come, you will get it simply. One thing is very simple thing, I can take the half commonly outside. So I already got the half, correct? So let me open it first and then do it. What will be, you tell me? So this will be x2 y1
minus x1 y1
y1
plus x2 y2 minus x1 y2.
This is right. You've done correctly. x2 y1 minus x1 y1 and x2 y2 minus x1. You put it in such a complicated way you are doing. Okay. Say tell me this one what will be? x3 y2 and
x3 y3
plus x3 y3
minus x2
y2 minus
x2
y3, and then this is minus, correct? Remember here is a minus is there. So this will be x3 y1, so minus x3 y1 minus x3 y3, and next one is minus become plus, correct? So what it will be?
Plus x1 y1
plus
x1
y1 plus
x1
y3. Correct? So let us take the x1 terms commonly outside. How many x1 terms are there?
Some can be subtracted. Minus
Oh, is there? Where?
x1 y1
Minus x1 y1? Oh, yeah, correct. Am I right? And
minus x3 y3
minus x3 y3, where it is?
Beside the x1 y1. Beside the x1 y1. Positive x1.
This one?
There. x3 y3.
Oh, yeah, this one with, yeah, this one, correct? And the x2 y2 also should be there. x2 y2, x2 y2. I think that's all should be. Am I right? Is there anything cancels off? x2 y1, no, x1 y2, and then x3 y2, x2 y3, x3 y1. Yeah, it won't get cancelled, right? So that will be half x2 y1 minus x1 y2 plus x3 y2, correct? Minus x2 y3. Is that right? Am I doing right? Minus x3 y. If I miss one term, we won't get the answer. Plus x1 y3. Correct? So now let me correct na? So now let me take okay, let me collect the x1 terms. These two, correct? I am going to combine them both. So what I will do, half, I will take x1 commonly outside from here. So this will be y3 minus y2, correct? And then I am going to take y1. y1 I will take minus y1. Where is the y1? Minus y1. If I take minus y1, so this will become x3 minus x2. Am I right? And then I will take x3. Sorry. What am I doing? Sorry. Oops. I will take x3 commonly. x2. Minus x2 I am common taking outside. So minus x2 if I take, what are the x2 terms we have? This one and this one, right? y3 minus y1. Okay, then I am going to take plus x3 also I am taking to common outside. So x3 when you take outside, y2 minus y1, correct? y1 na? y2 minus y1. I haven't missed anything, correct? So this straight away gives the answer, na? See now what happened? This will be equal to what? Half. I can write it as x1, x2, x3 and okay, and then I'll put here 1. Okay, and then I'll put y1, y2, y3. Isn't it that? x1 into y2 minus y3. So we are having the sign opposite, right? Then no, not a problem. Fine. Anyway, we will sort it out. x2 will be equal to correct. Exactly, sign is opposite.
But we have to change the 1 over into like that.
Yeah.
So that will be the.
No. When you rotate, it will be same. Okay. See, when you convert the rows into column and the columns into row of determinant will not change the value. Determinant will be same value. Only swapping of that. Okay. But it doesn't matter. The reason what I am saying is, so this will be equal to what we will have is minus, correct? Am I right? If I take one minus outside, is okay. So then this y2 minus y3. So and yeah, here also takes one minus y1 minus y3, correct? Like say now it is correct. So but doesn't matter for you because area is always positive. Okay. So what we have to do is, so therefore, when we say area, this should be mod of this. Since area always positive, so we have half. What is that? And of course, we can rotate also. You got it now? Because when you change the rows to column and column to rows, determinant is not going to change at all. Okay? So that will be what? Tell me. x1, x2, x3, y1, y2, y3, 1, 1, 1. So it is not, you have to you can either write like this or even this also. Both are one and the same. Okay, so this is the way we can actually find out the area of a triangle using determinants. Now, tell me if the area of a triangle comes out to be 0, what it means?
Determinant will be 0.
Alright, of course, that's what I am saying. Determinant is 0. If a determinant is 0, then what can you tell about these 3 points?
Then one single point.
One single point, or they are on a collinear. It's not a single point. They are collinear. When the 3 points are collinear, so then naturally area of a triangle will become 0. Correct? You don't remember? 10th standard you did lot of problems. So that's what. Simply find out the area of a triangle, and if you find the points are equal, so then these 3 points are collinear. Yeah, remember. So that's one thing. This is a very important thing. So the determinant, the area, since it is always positive, we can take it as a negative or positive, whatever it is. Okay. So now in the problem, when they gives you the area and ask you to find the coordinates of the points, you should remember determinant can be either positive or negative. So whichever is, you have to consider either the positive value of the determinant or the negative value of the determinant, the negative value of the area, and use the find the coordinates. Okay. So, and that's it. Yes, there is nothing else. Okay, in the next class we will do some problems. We will start doing, for the next classes we will take some all the problems starting from matrices onwards. Okay, so first we complete the whole theory part, and now we will take the problems.